Hello everyone. In this video, I'm going to take up examples on Karl Pearson coefficient of correlation, and for that I'll consider 5 examples of a different category. But before that, let us look into the definition, properties and formula part. So correlation is usually about the linear correlation, and it is a statistical tool for measuring degree and direction of linear relationship between the two variables. And when we say degree, it is always expressed by coefficient of correlation denoted by R, and it ranges between -1 to 1. And when we find the correlation, there are three situations we can come across. The number one is known as a positive correlation or also direct correlation. And this says that if one variable is increasing, other is also increasing, and vice versa, decreasing gives the other also decrease. So it is one of the example is a height weight combination, which is having one variable height, another variable weight. We always go with the positive direction, and same is for the income and expenditure luxury items. And when we say what do we mean by the negative correlation, which is the second category, or it is also known as inverse, that says that if one is increasing, other decrease, and if one is decreasing, other increase. So this kind of scenario is always declared the negative correlation. Price, demand on of commodity, driving speed and travel time are some examples. And when there is no change, when we don't observe one are changing with, so we say that there is no correlation. And it can be done with a different technique. One of them is a graphical one, scatter plot or scatter diagram. And what we can do, we plot the points as in coordinate on xy plane, and we can come across the situation like this. Let's say if you're observing all the points are trending upward direction with the positive slope, or we can say if there is a line and all are nearby the line, so they will give us a r value to be positive, and we can declare that as one is increasing, other is also increasing, so positive correlation. And when say we are observing the slope is in the downside, they are changing, one is changing, other is decreasing, means one is increasing, other is decreasing, or we can say the slope is negative. In that case, we can say a negative correlation, and r here comes a negative value. And when all points are scattered without giving any trend, no pattern, so we can say that there is no correlation and r is coming out to be 0. So these are the three situations, and specifically if we are observing that they are lying on the same line. Let's say we are observing that all the points are on the same line, we can say the perfect positive correlation, r will always turn up to be 1. And when all are on the line with the negative slope, all the points can plotted over there, so it can be declared the perfect negative correlation, and r value always turn up to be -1. And so what we can say, the scatter plot is also one way, because it is very useful tool for visualizing the data. And we can say what is a trend and what kind of relationship they have. And we can see that with the help of how far they are away from the line, we'll declare whether it is a weak negative, moderate positive. So these can give us a idea. But the disadvantage of this technique is we cannot give the exact degree of correlation via this method. So for that we have to rely on the formulas which gives us a coefficient of correlation. Two people has gave the formula. One is by Karl Pearson and another one is by Spearman's. So Karl Pearson coefficient of correlation is a covariance method, and it is also known as a product moment correlation. So in this video I am going to work with the problems of the Karl Pearson method of coefficient of correlation. And let's look into the formula part, that what are the formulas. So when we say the Karl Pearson, it is denoted by R, and it is the ratio of a covariance of the two variables with respect to the square root of the variance of x and y. So we have to take a product in the denominator, and we know that the symbol for variance is sigma x square and sigma y square, and the notation for covariance is sigma xy. So we know that when we take a square root of the variance, it is nothing but the standard deviation of x and standard deviation of y. So this formula is useful for some problem solving. And when we say how we can calculate these terms with these three terms, so we can make use of a different way. So right now here in my discussion, I'm using the expectation way to recall. So what we can do, if there is an expectation of any input, we can take a sum of those input and average it. So we get the expected value. N is a number of pairs of the coordinates. So when we say that what are the different formula which can apply, so there are two ways we can remember. What we can do, the first formula you can see here, we are finding expectation of the product of the deviated value from their respective means. So this is also a definition of a covariance, and we have also seen that it can be written in the simplified way by taking a e of xy minus ex into ey. So we can remember the formula in terms of expectation and then write down as an sum divided by n. So this way we can recall the formula of covariance, and in the same manner we can think of the variance. Variance is expectation of E, expectation of x minus x bar square, or we can find out this formula. So these are both formula for the variance, and we can write down as a summation because we will be given with the data entry. So we can implement these formulas for finding variance, and y can also be remembered in the same manner, e of y minus y bar square, or we can write down e of y square minus ey whole square. So these are the formulas, and when we plug in all these three terms in the formula, and it can be reduced as, if we use, let's say if we use the difference from their respective mean, so formula can be turned up in this way. Or it can be, we can also further reduce it into the simpler form. N is there in the denominator also under the root. So when you find out 1 by n square, root is 1 by n, and here also. So it can be rewritten in this form. And let's say if we are using the simplified formula version, so we can write the covariance divided by variance of square root of variance of x and y. And here also if we simplify n, so formula can be rewritten in this way. Sometimes some can use, because this is a x bar and this is an y bar, so here also this is y bar and this is x bar, we can express the formula in the another way. So these are all different way we can present the formula. And what else we can discuss right now here, that before switching over to the problem solving, let us look into some result and the properties. We know that +1 is for the perfect positive, -1 is for the perfect negative. So in between 0 to 1, if how we can identify what kind of strength it is. So let's say how we can say it is strong positive, moderate, or weak. So we can make a bracket of these numbers. There is no hard and fast rule, little change might be there, but yes, very close to +1 will give us a strong positive, close to 0 in a plus way it is weak, and in between if we are getting a value we can always say a moderate positive. In the same manner we can bifurcate the negative values as a weak, moderate, and strong to get an idea about what kind of strength the two variables are attaining. So these are some important point, and let's say the what are the properties we have already discussed, that range, perfect positive, perfect negative, and no correlation. The third property says that the sign of correlation depends upon the sign of covariance. This is variance of x and y upon standard deviation x, standard deviation of y, and always remember that the standard deviation of x and y, this is always positive, it will never be negative. It means r is coming out to be plus and minus, so it is only because of the covariance. So sign of covariance is also giving us a sign of coefficient of correlation. So this is positive, r is positive. If this is negative, r is negative. So that is one important property. And second is next is that when x and y are independent, they are always uncorrelated. How? Because we know that the covariance formula can be written in terms of the expectation of this formula, and when they are independent, the expectation of product is same as the product of the expectation. So in this case, when you take a difference of the same term, it is always zero. But there is a one point to take care: the converse is not true always. Why? Because if r is coming out to be the zero, doesn't mean that they are independent. I'll give an example for that. Let's say there are 2 points, and the pair of data of x and y is given, and when you take a sum of x and sum of y and the product, what we are observing, that covariance is calculated by the formula, because here this is also 0 and we are turning up x is also 0. So when we simplify it, I'll get r is equals to 0. But what we can observe here, that they are not independent. Why? Because y is the square of x. So we can say the converse is not true. And next, the last property which is useful in the problem solving of current 5 discussions, the correlation coefficient is independent of change of origin and scale. What does it mean? It means that even if we deviate the values, and even if we divide it or multiply by numbers, the new variable will always have a correlation value, but these value will match with the correlation of x and y. So usually this property is very useful, or we can consider for the those competition of the correlation where the values are very high or larger in the digits. Now let us come to the examples one by one. So example number 1 is to compute the coefficient of correlation between x and y. So we are observing here that x and y can be squared. We can directly solve it. So when we square x, y and their product, so we are going to get that x square is equals to 1. We get a 9, 25, then 7 square is 49, 8 square is 64, and 10 square is 100. In the same manner, what is y square? 8 square 64, 12 144, 15 225, 17 289, then 18 324, 20 is 400. Now here we can take a product of x and y, these two values. So we can say 8, then 3 into 12 36, 5 into 15 is 75, 7 into 17 is 119, 8 into 18 is 144, and 10 into 20 is 200. After finding these 5 columns, we can find out the sum of x, sum of y, sum of x square, sum of y square, and sum of x into y. So we can put these values in the formula which we have just discussed. So I am using this formula, wherein because if calculator is available, we can implement any of the formula. So right now the n value over here is equals to 6. So we have n is equals to 6, and when we plug in the values, so we will simplify it. After simplification, we get an answer 0.9879. So here it is a strong positive correlation. So strong positive correlation between them, because it is very close to 1. So this is the first example where data was given, no need of deviation, so we can directly solve it. Now let us see the next example. Here this example is saying the covariance of two perfectly correlated variables is 0.96. So the covariance of x and y is given as 0.96, and they are asking find the standard deviation of x and y. So they are asking what is the standard deviation of x and what is the standard deviation of y, where when it is known that variance of x and y are in the ratio of 4:5. So we know that variance is square of x standard deviation, so it is given as 4:9. So these are the value given to us. Now the point is, when this says perfectly correlated, what does it mean? And we are observing that perfect can be negative and positive. So right now perfect, we can take help of the covariance. Now covariance is positive, it means r is also positive. So it is a positive 1 value. So r is positive 1, covariance is equals to, which is sigma x into y, is equals to 0.96. Now we can calculate it. What we can do before that, we know that sigma x to the power sigma y. When we take a square root of this, we will get a 2 by 3. So we can get a value from here. Sigma x can be written as 2 by 3 times sigma y. So we got a relation. Now we know that r is equals to covariance of x and y upon standard deviation of x into standard deviation of y. So we are going to plug in the value. R is 1. Standard deviation of x and y is given as 0.96. Sigma of x, sigma of y is not given directly. They are given in terms of the ratio, so relation. So I'm going to substitute the value of x as a 2 by 3 times sigma y into sigma y. So when we simplify it, I can write down sigma y square in the numerator. We can shift this value here, and this side I'll get 3 by 2 times 0.96. So when we simplify, this will be 0.48, 1.44. So that is a 1.44 value for a sigma y square. So sigma y is equals to square root of positive square root of 1.44, which is equals to 1.2. So we got a sigma y is equals to 1.2. So one value is gotten, and sigma x I can substitute from here. So sigma x will be 2/3 of 1.2. So 2/3 of 1.2 means we are going to get 0.8. So we got a sigma of x is equals to 0.8. So this way we have calculated the required standard deviation. So this is a not data was given, some information was given, so we calculated it. Now let's see the third category of the problem. Here they are asking us to compute the coefficient of correlation between x and y from the following data. So x series, y series is given, number of terms are n here, so both are obviously pairwise, so n. Arithmetic mean means x bar is given to us, and here y bar is given to us. Sum of square of deviation from the mean, it means sum of x minus x bar, this is equals to 136, and y minus y bar square is given to 138. Next is the summation of product of deviation of x and y series from their respective mean. That means they have given us a sum of x minus x bar product with y minus y bar, that is given to us as 122. Now we can observe here, so the summed values are given, so we can directly, let us recall the formula. We can see that here the deviated formula which I discussed previously, that x minus x bar is divided by n is the covariance formula. Here we can apply the deviated from the mean formula, and even we can divide by n and both side, so it will reduce to more simpler. So I'm going to use this formula. What is that? This formula I'm going to use here. The three values are given us, so just we have to plug in the value of numerator is 122, and then we can divide by 136 square root and then 138. Now after simplification, these values we are going to get, we can make use of the calculator and it will give us an answer 0.89. It is also a strong positive correlation. So we got this example done. Now let's say this is a fourth example which is giving us a situation that a computer, while calculating correlation coefficient between two variables of a 25 pairs, observed the following information. Sum is given, all the sum, 5 sums are given which is required for that, but they said it was later discovered while checking that these two pairs were wrongly copied, whereas the correct pairs are these things. That means 6, 14 should be 8, 12, and 8, 6 should be 6, 8. So now we have to obtain the correct correlation value. So first of all, we have to edit our value. So what we can do is, with the help of sum, because they gave us sum of x is, previous sum of x is 125, and when we simplified, so these are the wrong value, these are the correct value, but both are same in sum, so our answer will be remain as 125. Now for the y, which is previously calculated 100, and the y values are 14 and 6, so we can delete 14 and 6 and add 12 and 8 from here. So we can get that minus 20 plus 20 will not change the previous answer, it will be remain as 100. And in case of x square, which is given as a 650, so when we squared 6 and 8 square, and here 8 square 6 square is to be added, they are same, so it will also not made a difference, so it will be remain as 650. Now when we are correct value of y square, previous value was 460, and when we simplify these values, so when we subtract it, what is giving us an answer to be 436. So we get a 436 answer here. Next is when we are simplifying 508, where we have to take a wrong product, delete it for first and second, and add the correct values after simplification of these values. So what we are going to get, we are going to get an answer to be 520. So you can cross verify these values. Now we are going to put them in the formula. So here n is equals to 25. So what we can do, when we substitute the value here, summation of xy is equals to 520. This time I am using this formula, and n is equals to 25 minus sum of x is equals to 125 divided by 25, and this is equals to 100 divided by 25. When we put it into the root, the first one is for x square is equals to 650 by 25 minus, now here I can, because this value is same as the value, so when we say 25, this is 5 and this is equals to 4. So we are getting 5 and 4. So basically this is for the x, so I am writing here that is 25, because we have to square the value. And in the another side we have a sum of y square, which is 436 upon 25 minus, I have to take y square, which is same this value. So we observe this is 4, so it will be 16. Just for the sake of time, I'm just simplifying it. So this is 5 4s are 20. So what we are getting, 520 minus which is equals to 500. Six 25 upon 25, this is 436 minus 400 by 25. So when we simplify, we are getting this is equals to 25 will be cancelled, and we are getting 20 upon root of 25, and this side is 36, which is equals to 20 by 5 into 6, and then after simplifying we are getting 2 by 3, and 2 by 3 is equals to 0.66, and so on. So we can write down 0.67, which is a moderate, we can say positive moderate correlation. So in the last example, I am going to take a data which is 2-digit number, and we are going to find a correlation coefficient with the help of change of origin. And what we will do, we are going to delete all the x values from a number and y values from a number, let's say b. A, B selection have, there is no hard and fast rule, but it should be as central as possible, so that some value become negative, some value will become positive of a 1 digit, so become a question easy. So what we can do, first preference is select mean. If mean is coming in the point, take near to the mean value. So right now when I selected, so I selected x as a 68 and y b as a, for y we selected 69, which turn out to be the x bar and y bar, so it can be anything else. So here when we put the value and we get this answer is a -3, the second one is -2, this value will be -1, -1, it is 0, 1, 2 and 4. And when we do for the y, we get a y -69 as a -2, this is -1, this value is -4, -1, this will be 3, 72 minus this is 302. And when we take a sum, this comes out to be 0, 0. And that's why mean always give a 0 answer. So u square is equals to here 9, 4, 1, 1, 0, 1, 4, 16. And this is equals to 4, 1, 16, 1, 9, 9, 0, 4. And when we take a product, it will be 6, 2, 4, 1, 0, 3, 0, 8. After taking a sum of u square turn out to be 36, sum of v square is coming out to be 44, and sum of u into v is coming out to be the 24. And here is a 8 value because there are 8 pairs. So when we are going to plug in, so what we are observing, that this value is equals to 0, this will also be 0, this value is coming out to be 0, this value is coming out to be 0. And when we plug in the value, so what we are getting n times summation of uv, and here we have a root of n summation of u square into root of n summation of v square. So in fact n and n will also get cancelled. So my answer will be only 24 upon root of 36 root of 44. And in this case when we simplify it, so we will get 0.603. So that is also a moderate positive. I hope you have understood the concept. Thank you so much.